Hello, everybody, and welcome to our Engineer the Materials of Tomorrow webinar. You're here this evening with us to learn all about our chemical and nanotechnology engineering programs here at the University of Waterloo. So thank you so much for joining us, and we're excited to share some of the strengths, some of the highlights, and of course, some of the student experiences that our students and our alumni have had within these programs. So before we get started, I just want to dedicate the first couple minutes to share some housekeeping rules, especially to make sure that you have a seamless and exciting experience with us online. So if you are looking to ask us any questions, you can submit questions using the Q&A button at the bottom of your screen. The same goes if you are needing closed captioning. That is available as well on the bottom of your screen through some of the functions of Zoom. With regards to getting your questions answered this evening, there will be two different ways for you to get your questions answered. You'll either receive a typed response from our incredible back-end admissions team, or you will be receiving we will have the opportunity to answer your question out loud during the panel portion of our event as well. And of course, at any point tonight or moving forward, if you've got any questions about our programs or about admissions, you can always email enginfo@uwaterloo.ca. So before we get into the event, I do want to take the next moment to do a territorial acknowledgement from the University of Waterloo. So the University of Waterloo acknowledges that much of our work takes place on the traditional territory of the neutral Anishinaabe and Haudenosaunee peoples. Our main campus is situated on the Haldimand Tract, the land promised to the Six Nations that includes 6 miles on each side of the Grand River. And our active work towards reconciliation takes place across our campuses through research, learning, teaching, and community building, and is centralized within our Indigenous Initiatives Office. Something that you're all encouraged to do is to visit native-land.ca to learn more about the land that each one of us occupies. Thank you for sharing this moment with myself. So I'm joined tonight by an incredible group of, I would like to say, experts. We've got faculty members, we've got department chairs, we've got lecturers, just from our professor standpoint. We've got some alumni, students who've just recently graduated in the program. So these are just a couple of the names that you'll get to meet tonight. They'll be sharing their some content just shortly. And as well, we've got 2 students who are currently studying in these programs that you'll get to meet in our panel portion of the event tonight as well. So there's going to be a lot of information shared today. We're going to be meeting lots of people. I just want to share that one great way for you to continue these conversations is through our NCHATS initiative, where you can connect on a one-to-one basis with our current students. These are for free, and you can sign up for as many as possible, where you get to be matched with a student of your interest. So if you want to learn more about chemical and nanotechnology engineering, this might be a great way and something for you to take note of for the future. In addition, we're not going to be able to spend too much time this evening referring to admissions information, even though that's probably very much so on your mind today. Just note that we've got some upcoming webinars in early January, all focused on admissions, and we'll be doing our best job to give you some tips when it comes to the application process. And then, of course, this is something that you might want to do right now or something to keep in mind in later as well, is there's many ways for you to connect with Waterloo Engineering. A lot of you may be accessible on social media, so you'll be pleased to hear that you can find us on Facebook, Instagram, LinkedIn, YouTube, Twitter, whatever it is, there's a channel for you to connect and engage with us. Awesome. So those are just a couple of those housekeeping items that I want to share with you all. We're going to dedicate the next bit of time to learning more in depth about these programs. And then once again, we'll have the remaining time to get your questions answered out loud. So on this note, we're going to start with chemical engineering. We've got a couple guests. I'm going to invite Sarah and Mario to the stage, to the virtual stage, I guess, to share a little bit more about chemical engineering. Perfect. So Sarah and Mario, feel free to introduce yourselves, and then let's get talking about chemical engineering.
Right. Hi, everybody. My name is Sarah Meunier. I'm a lecturer in the Department of Chemical Engineering here at the University of Waterloo. I'm so happy everybody is here.
Hi, everyone. I'm Mario Ioannidis. I'm a professor in the Department of Chemical Engineering, and as of recent, also the chair of the department. Very happy to have a chance to talk to you. Sorry, you're muted.
Oh, I'm sorry, Mario. I thought you were going to start off.
Oh no, oh, I think I was gonna. Okay, is this mine? All right. So folks, you have wondered, what chemical engineering is, and in one slide, if I were to summarize this in one sentence, I would say it is the engineering of transforming raw materials into products and energy, actually, not just other materials. To just take, raw materials and transform them in producing other materials and energy, because as you know, most things, we don't find naturally on Earth, and I'm not talking about cell phones. We also don't find hydrogen, in nature. We have to make it somehow. We don't find the hydrochloric acid in nature, and we don't find, most of the chemicals that are needed to synthesize other things, and from those other things, so that in the end you can make a cell phone. So the transformation, in other words, of raw materials, resources, basically, feedstocks, we call them in engineering, in other useful materials and energy is what we do. And that addresses a large number of problems of relevance to the entire civilization. So I can give you just a few examples, that are relevant nowadays. You know that we need fertilizers to make food for the world. The population is growing, and in order to make fertilizer, we take a mineral that contains the element P, phosphorus, and from that we try to make phosphoric acid. We react it, and from that we make a catalyst, a pellet of fertilizer that we spread, in fields to grow the crops. But as you probably know, there is only so many atoms, the element P on the planet. And after we have dispersed them all over the globe, we need to somehow collect them again in order to continue, this fertilization process. So many problems like that exist nowadays in the 21st century that chemical engineers need to address. One of them being energy, right? To get it not from fossil fuels. And this is where chemical engineering is going to be very important. Patricia, can I get this next slide? Yeah, so that's you, Sarah, is it, or just me again? No, just me again? Okay, well, I'll just give you an example, that is very, very dear to me. Everybody knows penicillin, right? And how it cures infection. Who invented penicillin? Some guy by the name of Fleming, right? He discovered it, right? Fleming was not an engineer. He was a scientist, brilliant one. He discovered penicillin. He had one patient, Fleming, and the patient died because Fleming could not make enough penicillin in sufficient purity to cure that person. And it took a couple of chemical engineers to figure out the process that would make large amounts of penicillin of high purity to save the lives of thousands of soldiers in the First World War. And these chemical engineers, believe it or not, they were behind a company that goes by the name Pfizer. And now it's very popular, for their vaccines, which are also produced, by processes that chemical engineers bring to large scale, which is what we do. Food, I already talked to you about. Sustainability, this is our main thing. You must have heard about Sustainable Development Goals. UN has called them out, and we need to advance them in this decade, which is your decade, the decade you're going to be in school. And by the end of that decade, in 2030, we should have solved all of those problems, that are defined in Sustainable Development Goals of the United Nations. So I would say that our discipline is best, positioned to give answers to these global problems. Patricia? Looks like it's Sarah talking now.
I can go from here. Thanks, Mario. So I want to spend just a minute talking about academics for chemical engineers. Basically, we start with our core courses. So there's a lot of science and math. Once we get that solid foundation, we start studying process-based courses like reaction engineering, bioprocess engineering, heat transfer thermodynamics. And of course, just like every other type of engineer, chemical engineers like to work with big processes and big data. So we have another group of courses that involve things like data management, process control, simulation, optimization. In the first few years of our degree, chemical engineers are mostly committed to taking those core courses. Once we have a really good understanding of the important chemical engineering concepts, we can branch out and take electives that focus on fields that we want to discover in more detail, so fields that interest us. In our program specifically, we have the opportunity to tailor our electives to specialize in certain areas. We currently have 3 specializations. The first one is energy and environment. So things like pollution control, green energy, that sustainability side of things. Then we have materials and manufacturing. So things like polymers, composite materials. And the last one is modeling, optimization, and control. To get a specialization, we take courses from a directed list. So it doesn't actually add any additional time to our studies. It just recognizes that we focused our course choices in particular area of chemical engineering. So since we're not, well, you guys are not on campus, some of us might be on campus, I just want to give you a sneak peek into what campus looks like for chemical engineers. E6, that's the first picture that you see, is our chemical engineering headquarters. And that's where you'll find most of the professors in chemical engineering, as well as research labs, classrooms, study areas. And we have a lab specifically for our undergraduate final project, which I'll talk about a little bit later. DWE, that's our original chemical engineering building. So that's the one in the middle. And we spend a lot of time there because we have classrooms, student labs, our student society office. And then spread across the other engineering buildings, you'll find resources like the machine shop, the prototyping center, paint shop, and a lot of other classrooms. Would you like to take that one, Mario?
No, that's no, I'll take that. One good thing, about our program is that which is also encountered, in nanotechnology engineering and in some other programs, but not most of them. So this is really not the rule, but it's a really good thing, is the possibility of long, co-op terms, because so each of our streams has equal opportunity to in senior years to do co-op for 8 consecutive terms, which could be with the same company or with different ones. There is flexibility for that. So this is a very good feature because it allows this most senior students to take increasingly complex, roles, right? That require them to stay there for longer times. So that's a really good part of the program. As you can see here in the box, there is a tiny list, of the very many companies that that employ chemical engineers. Pretty much any processing, of materials and energy will involve chemical engineers. There is no way, to do without. And it can be anybody, from auto manufacturers to raw materials processing, steel, and what have you, food processing, and everything else. So really, this list is by no means exhaustive. Yeah, let's move on. Sarah?
All right, so after doing that long co-op term that Mario mentioned, our 4th year students now do 8 months straight in school to finish up their degree. And one of the reasons that we like to do that is because we have this big final design project that students do in their 4th year. So it allows an opportunity to have 8 months in school to really work on that project all in one huge chunk. We call this project our capstone project. So this project could be anything that really inspires our students. So it could be something that they found on a work term, a project that a professor is interested in, something they've come across in their studies or in everyday life. There are tons and tons of different options. What you see in the box on the gray box on the right-hand side is a sample of some of last year's project titles. And the rest of the slide just highlights one particular group's project from last year. Min, Nishita, Andy, and Gavin came up with UW Tencel, which provides a biodegradable replacement for disposable cutlery. They won 2 pitch competitions for their project, the Norman Esch Entrepreneurship Award, as well as the Velocity Concept. So really these design projects that our students work on show just how much our students have learned in their undergraduate degree.
And I was going to say that there is springboard for entrepreneurship, of which you're going to hear, more, I think, later on, right? So this is really the challenge here for chemical engineers. In the past, we have been making plastic from basically hydrocarbons, petroleum, right? So now the challenge is to make plastic from pine cones. So this is the chemical engineering of the 21st century, to replace the old feedstock with sustainable one.
All right, so I just want to leave you with some ideas about the amazing things that chemical engineers do. Chemical engineers are entrepreneurs, they are consultants, they are plant designers, safety engineers. There's a ton of different job titles. We're all just chemical engineers. We design products and processes. We analyze and improve processes, manage teams, departments, even entire companies, which you're soon going to find out a lot about. You can find chemical engineers in just about every industry: polymers, biotechnology, automotive, and energy, fuels, consumer products. We're everywhere, and we're looking for more people to join us. So now I would like to introduce an alumni of our program. Kaylee graduated in 2020, so I'll give the stage to you, Kaylee, so you can introduce yourself.
Thanks, Sarah. So yeah, my name is Kaylee. I graduated from chemical engineering in 2020, so right at the beginning of the pandemic. I made it out very nearly at the end there. And I started my own company right after graduating with one of my classmates, actually, who is also a chemical engineer. And so I've been doing that for the past 1.5 years, almost 2 years now. And what we do is we're building a centralized reusable packaging system to eliminate single-use waste. So kind of along the same lines of what Mario and Sarah were talking about earlier, kind of focusing my degree towards a sustainable path and kind of building something really big. So while I was at Waterloo, I had 6 co-op terms. So we had 6 4-month terms. And I worked in a variety of industries and a lot of different roles. So I started out at the beginning, kind of you just want to get in there and take what you can get and really get some experience under your belt. I didn't have any experience going into my program, and so it was awesome to be able to get that right off of the bat. I worked in kind of research with Natural Resources Canada in Ottawa. I worked as literally a manager of 30 individuals at a GM plant in Ingersoll, which was a big kind of leadership role for a student. I worked at Mondelez, where we made Oreos and wheat thins and veggie thins, and we were actually opening up a whole nother line. So they had built pretty much a whole new plant, and I got to work on starting up that whole line. And then I also spent some time at a startup called Ex Vivo in Waterloo. And that was where I was introduced to the idea of startups and entrepreneurship and what that could look like. And that sparked my interest in the area. And then my final term, I worked as an operations engineering student at a chemical plant called Solvay, where I really got to apply everything I'd learned. And so that was a cool experience as well. So pretty much every one of my co-ops was spent in a completely different industry and in very different roles. And I got to see kind of what I liked, what I didn't like, and figure out where I wanted to focus once I was finished. So my current job title is CEO at Friendlier. That's the company I've built. And my top tip for landing a co-op job as an employer now myself would be research the job and company. It makes a huge difference when we're receiving co-op applications if you can tell that the student has actually researched and they actually really want to work for your company. So I loved a lot about my time at Waterloo. The biggest thing I would say that differentiates Waterloo is the co-ops. So again, I touched on it, but you get the chance to see so many different roles and get so much different experience and figure out what you want to do before you get thrown out into the world. And you also get usually a lot of job offers and opportunities to go back to those companies, which is really cool. I also made all of my best friends during my time there. This is a picture of us outside of one of the engineering buildings that Sarah was showing at one of the engineering events. And so there's always lots going on, and you really rely on your friends as your support system when you're going through whatever engineering program. I think they're all just as tough. And then I also had the opportunity to go on an exchange. I went to Sweden for 4 months in my third year, which was an incredible experience. I would highly suggest it to anyone going into university. It was super cool and just awesome to be able to see a whole another way of doing things and schooling and getting to travel and get a whole bunch of new experiences. And then I would say the biggest thing when people ask me, how does chemical engineering relate to what you're doing? I say it taught me how to solve problems and be confident tackling a really big problem. So we're trying to build this massive process out in the real world where we're reusing products and bringing them back and recirculating them. And it's very overwhelming, but what chemical engineering gave me was the ability to break down a big problem into smaller pieces and to be able to kind of optimize those subsets of problems to be able to solve things that previous to engineering, I would never have felt like I could solve.
Amazing. Thank you so much, Kaylee. Also, the previous thank you to both Sarah and Mario. That concludes our chemical engineering portion of the day. Kaylee, you're going to have to pop in the name of your company's website so the students can check it out as well, just to see more about the work that you're doing. But of course, you'll be meeting these previous presenters in our panel discussion coming up. Switching gears a little bit, but not too far away, we're going to be focusing the next couple of minutes all about nanotechnology. So on that note, I would like to bring Pink to the virtual stage to kick us off and tell us more about this incredible program.
Hello, everybody. All right. Hi. Hi. I'm Tane, and I'm Associate Professor in Chemical Engineering, but I'm also the Program Director for the Nanotechnology Engineering program. Slide, please. So what I'm going to do is I'm going to give you some idea what nanotechnology engineering is all about. So as the name implies, we like to study things small. We are doing things, making things small. So small scale fabrication, small scale study. But however, we are going to make a lot of big impacts to everybody's life. And we study the science, engineering, and technologies in nanometer scale. So this is not a gimmick engineering. Actually, this program or this discipline has been recognized by the professional engineers of Ontario. So this is a hardcore engineering program, just like civil engineering, or chemical engineering, and electrical engineering. It's a real discipline. It's recognized by the professional engineers of Ontario. And this program will be interested by those that who is like electrical and chemical engineering, chemistry, biology, and physics. And over here on the right hand side, you see little pictures over here. It's actually a picture of the clean room that are dedicated for the nanotechnology engineering students. And this particular person is actually working on a machine for photolithography. Next. So what is nanotechnology engineering? Okay, so there are many, many examples, but the most important one right now is the COVID vaccine. So some of you know that there's a type of COVID vaccine, it's called mRNA. So what is happening is we will synthesize the mRNA molecules, and then we will encapsulate them in the lipid nanoparticle, which is the COVID vaccine. And then it's going to inject to wherever want to inoculate it, and then it goes into the cells, and then we develop the immune response. So this is a classic examples of nanotechnologies. If you have a COVID vaccine with a mRNA in it, so you have part of the nanotechnologies inside your body already. So this is just a perfect examples that how nanotechnology engineering can develop something very useful, very important, such as the COVID vaccines, and which may possibly save millions of lives already. So what do nanotechnology engineers do? So we use the principles from engineering, biology, chemistry, electronics, and quantum physics to create some materials or machines or devices that's so small they cannot see with your naked eyes. So a lot of them is going to be in micron or nanometer scale. And we also design systems with dimension in nanometer scale, nanometer, which means in a billionth of a meter. So it's like to control objects or structures in atomic scale. Next slide, please. So what do you learn in the nanotech program? During the first year, actually, in fact, the first term, you learn some of the basic fundamentals such as calculus for engineers, Calc 1, linear algebras, and then you also study societal and environmental impact by the nanotechnologies. And then you also take a class in programming. Okay, so it's a computer programming. And then you also learn chemical principles. And in addition to classwork, we also get to go to the lab. So you develop hands-on laboratory skills, and we will teach you how to use CAD or computer aided design. So basically, it's a program that you can design your own objects, okay? And then you can prototype it in using a 3D printer in our lab. So you can develop some concept, you can make certain objects, design certain features, and then you can actually prototype it to make it as a solid in front of you. So we have the facility that enable you how to develop ideas into a product. In the upper years, okay, you can actually more focus in different nano area. For example, biology area or nanobio area, you can have classes in organic and biochemistry, nanotoxicologies, nanoscale biosystem. And then in material science, you also study nanostructured materials, soft materials, or in advanced polymers. And then you also would learn more math, okay, much more advanced levels, such as advanced calculus, so that you can perform computer simulations to understand what's happening in nanometer scale. Okay, and then you can also learn semiconductor physics, such that you can design a nanoelectronic devices. Not only you learn the theories, we also have clean rooms such that you can go in and fabricate and prototype yourself. So we'll teach you how to do that, and we'll teach you some classes such as nanoprobing and lithographies. So you can develop ideas, and then you can prototype it and to be a final product, and then test it all within our labs. This is how the co-op structure for nanotech looks like. During the first year, you will have finished 1A and 1B in class, and then you do go to co-ops, okay? And then you go back to campus in 2A, and then stay here in the fall term, and then go back to co-op in the winter, and then go back to class in 2B in the springtime, and then you start your 8-month co-op. So basically, you have back-to-back 8-month continuous co-op term, and then you come back to school for 3A and 3B, and then you perform the final 2 co-ops, which is co-op number 5 and co-op number 6. So again, it's a 8 months co-op. And over here on the right-hand side table show you the average rate of play in 2020. This is from Faculty of Engineers. So it's a pretty big range. As you go to much more advanced closer to graduation, as you can see, your pay also getting increased. Now, the photos over here at the bottom is actually taken in our lab. It shows a silicon substrate wafer with some device on it, and it's being probed by what we call a microprober. And you can see the probing needles actually contacting the device. Okay, next please. So where do people go during the co-op term? So it depends on what you like to do or what area you like to explore. In academics, so people would like to go to different places to conduct research. Many of us or many of the students went to Harvard, MIT, and if you'd like to go to Europe, you can go to Zurich, ETH Zurich, and also Cambridge. There are quite many students have been there to perform research during co-ops throughout the years. And you can go through healthcare, you can go to sick kids or some other hospitals. You can develop new materials. We have a lot of students go to Apple and also Tesla for the battery design, and also Bombardiers for much other like airplane or train metallurgy kind of design or development during the co-op terms. You can also do consulting. If you like to software, we also have many students actually do co-ops in different software companies such as Facebook and some Google, and they have some banks also. We have some software divisions also like to hire co-ops. Hardware, so we are talking about electronics, okay? So we have a student went to AMD. The AMD has a branch in Markham, and then analog devices, some of them in the US, and then also in Broadcom. Some of them went to government agencies. So NRC, National Research Council of Canada, and some of them went to NASA, Jet Propulsion Laboratory. So there are many different options. This list is by no means complete, but just give you some taste, some idea what kind of options you can do during co-op terms. It's all over the world, all over the place. So what do you do after you graduate? Okay, so this is a pie chart, okay, showing you what kind of jobs our alumni went to. And this is the average between 2015 and 2019. As you can see, a big portion of it went to semiconductor industry in electronics. There's some in Canada and some of them in the US. And then a lot of them went to healthcare and pharmaceuticals. As I give you a good example, the COVID vaccine is belong to the healthcare and pharmaceutical area. And then manufacturing, a lot of them went to software, okay, as I mentioned before. And then business and finance is also a big area because a lot of time when you have $1 billion fund, mutual fund, and some people want to some experts to come in and tell them what stock to buy. So there's a lot of area in this area. Jobs went into this area. The photos on the right-hand side actually is another pictures of our clean room showing another person actually operating a what we call a PVD machine, physical vapor deposition machine, a big chambers over here. So when you go to your upper years, you will actually have opportunity to work in a clean room like this one. Next, please. So what areas do nanotechnology engineering impacts? As I mentioned before, our alumni go to all different areas, different such as electrical engineering, engineering sector, energy sectors, materials, computations, bio, and then optical engineering. So bio is a big one right now. So you got bio sensors, vaccine development, drug deliveries, medical imaging. It's all pretty much really high on the news every day. And software, there are a lot of area jobs out there in the software area. And then we also have semiconductors. A big portion of alumni went to the semiconductor companies, microelectronics. And then we have nano instruments, we have battery designs, and then also cosmetic and construction areas. So they go to many different sectors, and they all have big impacts in each of sectors. Next, please. So why nanotechnology engineering at Waterloo? There are many, many reasons. Okay, I can spend an hour, maybe 2 hours to talk about it. First of all, we have a pretty nice big building, as you've seen over here. This is a hexagonal building, is where your classroom mostly going to be. And then also the lab is in this hexagonal building over here, as you can see. It's very new. We just finished it a few years back. And we also have a lot of facility, as I mentioned before, allow students to use computer to design and then prototype it. And one of the alumni groups able to win a competition in a champion in 2020 Canadian Engineering competition for innovative design. So check it out. They have our alumni constantly win a lot of different competitions. They build prototypes and able to do this in our labs. One of the unique features about programs in Waterloo is we have a dedicated clean room for our students. It's only for the NE students for class and also for prototype and also for their senior design projects. And it's more than 1,000 square feet. It has lithography facilities, so they can print and fabricate whatever devices that they like to produce. So that allow our students to be able to prototype very quickly. And also one of the reasons we are able to win a lot of competitions, our students. Okay, so and a graduate pursue jobs in startup and many industries, as you showed before. This program allows us to allow the student to go to different sectors, and also they can continue for advanced degrees. And we actually have quite a few alumni become professors at different universities in the US. I think one of them become professor at MIT, and another one is in Purdue. And okay, so that's actually another little yellow pictures. I'm sorry, pictures there. The yellow pictures over here actually shows a silicon wafer again with some prototypes on it. Okay, so this is some of the specimens you guys can make for yourself while you're studying in the nanotechnology program. Next, please. Okay, so with this, I would like to introduce one of our distinguished alumni, Erica, and here we go. Erica, I'll let you take over.
Thank you. Okay, there we go. So yeah, my name's Annika. I graduated from Nanotechnology Engineering this past May in 2021. And yeah, I am now CEO and co-founder of my own company, which stemmed from the fourth year design project or capstone project that we work on in our last year of engineering. So throughout my time at Waterloo, like Ting mentioned, we have 2 4-month co-ops and 2 8-month co-ops. So my first co-op, I really got like a diverse experience. I got to work at a software company in Toronto, and I was working more of like a consultant role, so kind of working on materials that would go directly to the customer, and that was a really cool like first job, especially going from like high school part-time jobs into like an office space. Is a really interesting experience. And then my second co-op, I worked at BWXT in more of an engineering role, and they design and develop machinery for nuclear power plants. So that was really fun to kind of like learn about that side of things. And then I spent my first 8-month co-op at a startup company called Santec, where we were developing a breathalyzer for marijuana. And that I think was one of my most rewarding co-ops because I got to do a lot. I was trusted with a lot of responsibility, and I got to work in the lab almost every day and kind of lead my own projects and do my research, and then test that research in the lab to help develop the sensors that were being used in their breathalyzer. So I did end up splitting my last co-op, my second 8-month co-op, into 2 4-month co-ops, because I spent the first half of it back at Santec. And then for the second half of that last co-op, I went to another company called Nicoya Life, which is a startup company, but a bit bigger here in Waterloo, which actually was also founded from nanotechnology engineering grads from like the first class of graduates, I think. And they are developing what's called a surface plasma resonance machine or equipment for the lab that basically helps other labs do like drug discovery and stuff like that. So I was also working on biosensors there. And then, like I mentioned, now I am founder of my own company called AlgoBio, where we are developing a non-toxic flame retardant. And like I said, the technology aspect of this was developed in our 4th-year design project. But the kind of inspiration to work on this problem came from a 1st-year toxicology class from 1st-year nano engineering. So we learned kind of about the toxic impacts that many chemicals and nanoparticles, and including flame retardants, can have on the environment and human health. And so that was a problem that me and my team really wanted to work on. So we developed that technology, and they're now turning it into a company. And my top tip for working on or for landing a co-op is to write a like meaningful, specific cover letter. So if you're kind of really passionate about a certain job or working at a certain place, kind of like pulling out things that may be important to the company or important to that role are super important. So kind of like doing a background on the company, showing like why you're passionate about working there, and maybe why you think you would like be a great fit for that specific role. I think that really makes you stand out. And then what I specifically love about engineering, so like Professor Ting mentioned, the great thing about nanotechnology engineering is that you can, in your 4th year, kind of diversify, or you're diversified in 1st year, and then in 4th year you can like choose specific courses. So nanotechnology engineering starts out, you kind of like learn a lot of broad aspects. So you learn like some software and electronics, materials, biology, chemistry, kind of get a little bit of everything. And then when you go into your later years, you can specify. And like you mentioned, you can go more specifically into like materials or electronics. And I chose to go down the biotechnology or medicine route. So I got to learn a lot about how nanotechnology is impacting medicine and making a big difference in that field, and biotechnology in general. I think my favorite thing I learned there was targeted drug delivery for cancer treatment. So that was a really interesting course in 4th year. And then I also got the opportunity to do an exchange. So I went to the Netherlands for 5 months. And I did that on my 3B term, so my second half of my 3rd year. And that was an amazing experience. I really got to like immerse myself in the culture there. The school that I went to there, TU Delft, was amazing. And I think nanotechnology engineering is a great program that really allows you to do exchange, because they're pretty flexible in terms of like matching up your courses to qualify or be match up to like the Waterloo courses. So yeah, it was a pretty easy process, and I would recommend anyone to do it. And then also like the co-op experience is just super valuable. Like that's one of my main reasons for choosing University of Waterloo. And basically just because you graduate with like 2 years of work experience, and I don't think you can really get that anywhere else. And then of course the 4th year design project was a super impactful part of nanotechnology engineering, because it is very cool to like design something yourself from like start to finish. And for me, it meant a little bit more because it was the technology that helped me start my company.
Amazing. Thank you so much, Annika. It's so great to hear that both you and Kaylee got the ability to go abroad during one of your academic terms. And similar to you, please pop in and share some info about your company, because I imagine our audience here wants to know a lot more about it. So fantastic. Thank you, Annika. Thank you, Ting, as well. On this note, this concludes our presentation portion of the evening. We hope you stick around so that we can get into answering some of your questions live. But just a couple quick reminders that you can connect through an end chat, email us at enginfo@uwaterloo.ca, and there's also opportunities for you to connect through our live online chat function too. So thanks so much. And on this note, I will stop sharing my screen and invite all of our experts. And of course, 2 people that you haven't met yet will be joining us in a second that are current students that will want to learn more about. Perfect. So everybody, please join me here on the virtual stage. Wonderful. I forgot to encourage all of our panelists, if you can rename yourself to include the program that you're representing so that our audience members, in case they have tuned in a little bit later, they can get a sense of what program that you're representing. Perfect. So I think we're just missing Annika, and then I think we are ready to go. There she is. Okay, we've got the full group here. I'm going to start with Annette and Nuseba because our audience hasn't had the chance to hear from you both yet. So Annette and Nuseba, the first exciting question that's coming your way is that we want to hear, as you didn't apply too long ago, what inspired you to choose chemical engineering for you, Nuseba, which we'll start with you, and then Annette will go to you next to tell us what made you choose nanotechnology engineering. So Nuseba, please say hello to our group and let us know what inspired you to choose chemical engineering.
Yeah, hi everyone. So I guess when I was in high school, I always just kind of enjoyed math and science courses and kind of had an aptitude for it in general. And then I had kind of been exposed to engineering through teachers and my older brothers in mechanical engineering. So I kind of did research into the different disciplines of engineering. And with chemical engineering, I really liked the different industries you could go into. So of course, during this webinar, you would have heard some of the examples like pharmaceutical, food engineering, any sort of manufacturing plant you can work in. So really just the versatility of the degree was really appealing to me. And just being able to be a part of industries that touched so many lives. Like, for example, if you're working in the food industry, you can see your products on the shelf in any grocery store or, you know, things like that. Or if you're working in battery, I did battery research for my first co-op. So knowing that that's being used in cars that everyday people use, I think that idea and that concept would really appeal to me. So definitely the versatility and just the fact that the industries that you could work in really affected everyday lives. So yeah, that's why I chose chemical engineering.
Wonderful, wonderful, great response. Thank you for kicking us off. And over to you, Annette. Let's hear your story behind nanotechnology engineering.
Yeah, hi everyone, I'm Nanette. Nice to see you all. Funny thing is, actually, originally, I wanted to do materials science and engineering. So that was what I originally was interested in. This is going to sound like very similar, but part of the reason why I was interested in the material science and engineering is because of its like applicability to so many different industries. And so it was actually kind of later in my university application process that I sort of chose nano, because originally I went to open house and I think I was asking around at Waterloo's booth to figure out what program they had that was the closest to material science or engineering, and nano was the one that they told me about. But it's definitely not a choice I regret. Another excellent factor in my decision was the co-op program at Waterloo. So that has been just really invaluable. And yeah, so I mean, another thing about nano is that it's full of really actually cutting edge developments and technologies going on. So it's really, really exciting to kind of learn and be a part of it.
Wonderful. Well, we're very happy, Annette, that you're in the nanotechnology program, and fantastic. Thank you so much for sharing that. Related to kind of what Annette has shared, and actually a question that came through from our audience members. So this question is coming to you, Tank. For somebody that might be confused between nanotechnology and materials engineering. So how could you differentiate those programs?
Oh, that's a good question. So nanotechnology actually composed of many different sectors. Not material is only one of them. So, for example, biologies like the COVID vaccine, that's a pure bio related. So they are not really related with the traditional materials engineering that most people would think of. Making a nanoparticles from a lipids. So they're all organic chemistry. components in it. So that's quite important. And the other one is a nanoelectronics. So there's a lot of components related with circuit design, which the traditional materials engineers would not have the background to it. So, we do have a materials components. For example, develop a new super strong materials, super lightweight materials. Those are similar to what the materials engineers, but we will maybe focus on how to use a small scale type of manipulation in atomic scale to affect the materials properties electrically, mechanically, or chemically.
Wonderful. Thank you so much, Ting. I have to take notes. That's some great information that you're sharing. Perfect. So I'm going to move on to Kaylee and Annika here as our alumni students. That's probably not the correct term, but anywho, they have graduated from the Faculty of Engineering here at the University of Waterloo. And you've also heard from their little presentations that they're entrepreneurs, and you're both quite fresh outside of the university. So how could you think, when you think back to your experiences, I know you both shared a little bit about kind of what was that spark, but a lot of people have ideas and they're thinking about being an entrepreneur, but you both went ahead and did it. So what was that inspiration, and how do you look back to your experiences as a student, and how did that impact truly where you are today? So Kaylee, let's get started with you for that question.
Yeah, for sure. That's a great question. I think I really hadn't heard about the startup industry or even thought about entrepreneurship until my third year. So it wasn't until later in my undergrad that I even came in contact with that whole world. And I really loved it and was super interested in it once I tried it out at one of my co-op terms, but I still wasn't sure. So it wasn't like I was like immediately, yes, I'm going to go do that. I think for me, I got to see so many different problems during my co-op terms. And for me personally, the problem I'm tackling, I was really interested in because I saw, all the waste that was generated. When you see it in industry, it's all together. You realize how big problems are. And so that's what inspired me to do it. But I was really confident not really confident. I don't think anyone's that confident going out and starting their own company, but I was confident enough to do it because I had gotten all these different experiences and I knew a lot about the different industries that I was working in, and manufacturing and, business development and product development and all these different components that went into starting a company. And so I had enough knowledge that I felt I could at least start. And I think, again, it goes back to kind of what I was saying about being able to problem solve and being able to take a really big problem and break it down into its components. And that's a lot of what chemical engineering is. It's, how do I get one, raw material into this completely different product or thing? And there's a lot of steps to get there, but that's kind of what chemical engineering gave me, is the ability to break those problems down.
Awesome. That's great to hear, Kaylee. Thank you so much. And Annika, how about yourself? Oh, you're muted, Annika. It has to happen at one point in tonight's webinar, so all is well.
Yeah, I actually learned about like entrepreneurship and just the idea of starting your own company in one of the seminars before I even chose nanotechnology engineering, and that interested me so much, and I think that was a little bit of the reason of why I chose the program, because it seemed like there was so much innovation in this program and such new technologies coming out of it, and also a lot of startups seem to stem from this program. So from my first co-op, I was set on working at a startup and getting that experience. My first co-op was at a smaller company, maybe around 200 people. And then, like I mentioned, I worked at two other startups. One was about 5 people and one was about 50. So I really got the experience of seeing these companies at these different stages. And I think that really inspired me to want to start my own company. And it also gave me the resources and tools to be able to do it. I was always like cautious and only wanted to do it if like we did have a really good idea. And then like once we had the technology working really well from our 4th year design project, it just everything kind of fell together and it kind of seemed like the right decision.
Awesome, awesome. Well, congratulations to you both on taking that leap and all the success you've had in such a short time frame. I think you're going to be inspiring both Annette and Nuseba because you haven't graduated just yet to maybe consider starting their own company. Not to say that that's the only, as we highlighted today from both Sarah and Ting's end, that there are so many pathways and career opportunities, but it is pretty special that you both started your own company. So Sarah, I'm going to throw the next question your way. As a professor, a lot of students come into university nervous about interacting with professors. So my question for you is, how would you describe the professor to student experience? Is it easy to connect with professors, maybe for a research opportunity or just for homework help? So what advice would you pass along in this regard?
Just do it. Most every faculty member has at least somewhat of an open door policy. My door is always open and usually students walk by and it's closed and they're like, what's going on? We can't, what do you mean we can't stop by? If it's not an open door policy, there are listed times when professors are available for help. We have all kinds of events that we do on campus just to help students learn to talk to us and learn that we're real people and not big scary, I don't know. But we have so we have events and we're here and we love talking to people. That's why we're in these jobs. Because that's what we want to connect with students and we want to talk to people. So just reach out, send us emails, raise up your hand in class, come talk to us after class. We want to help you. But there's a step on the student side that students have to take one step, but we'll meet you halfway. So just reach out to us. We're not as scary as I don't think that we're as intimidating as students think we are once they start talking.
Wonderful. And Sarah and Ting, you have to be aware of your email inboxes over the next couple of days because you both now given the invitation for everybody to connect with you. So, but I think you're both welcome to it. So awesome to hear. Nuseba, I'm coming your way just to share a little bit more about the in-class experience. How many students are, we talk about, Waterloo Engineering being such a big faculty, but there's also something called cohort systems. Can you talk a little bit about that in your experience in the classroom setting in terms of class sizes and making friends and keeping those friendships through your time in undergrad?
Yeah, for sure. I think the cohort system is one of my favorite parts of going to Waterloo. So basically the way it works is you start off, at least with chemical engineering, we started off with around 150 students in the first term. And then we obviously have stream 4 and stream 8 that was briefly touched upon in the webinar. But essentially it's just it just has to do with your co-op schedule and when you go on your first co-op. So when the streaming kind of starts, your class gets split up. So kind of around 75 students. And then you're kind of with those people pretty much for the rest of your time at Waterloo. And then usually in 4th year, you'll all come back together to be one class. But the cohort system is really awesome because you get to be with the same people. You share all your classes together. So it's a really good way to foster some really strong friendships and relationships with each other. I know like in our class, I think everyone pretty much knows each other, even if they're not best friends, we're all like acquaintances at least. So I distinctly remember having memories of like tutorials where everybody would be running around to each other to like help each other. So there's a lot of camaraderie there. Also my close friend group, we met in 1A just because we shared tutorials or lectures together and we've been together ever since. So it's really unique to Waterloo that you get to stay with these people and you don't get separated with different classes. And it's really cool because after, university, you have a really good group of friends. You've been through a lot together. You did engineering together. So the cohort system really helps with fostering those really close relationships.
Love it. And it's so happy to hear that, because that is a common thing that I tend to hear from a lot of our students, that that cohort system really makes the community aspect so important and creates that ease within the academic setting as well. Annette, I know you're graduating you're almost there. You're coming up to the end of your academic degree. Looking back, what's been your favorite course in nanotechnology engineering?
That is a really hard question. I think in terms of like what I would choose as my favorite course, there's like multiple criteria I could consider. Like, sometimes it's more about the content, and sometimes I just really love the professor. Yeah, and I've had Ting before, so I'm looking at him right now. Yeah. Yeah, it's really hard to say. I mean, there's like courses that stand out each term. Maybe I'll narrow things down to perhaps this term. Right now I'm taking a few electives, so these are like courses I get to choose. So actually I would say maybe my favorite could be like it's NE 481. So it's like an intro to like I think I can't remember the exact title, but it's all about the nanobio stuff. And it's kind of a little so as the title goes, it's a bit of an intro, but it's talking about like drug delivery, all that good stuff, that if you're into the nanobio side of things, it's very interesting. So I'm enjoying the content a lot. Yeah.
Amazing, amazing. I think you had the best response, that it is a tough question, because there are so many courses that bring out different pieces, and I love that you mentioned it also matters just on some of the professors that get to teach some of those courses. So I think that's a really great reflection, and yeah, I couldn't imagine answering that question myself, but it's great to know again that there's many options of courses that you have seemed to enjoy in your undergrad. So I know we are wrapping up here on time. There's thousands of questions that I want to ask each of the panelists. I'm going to bring it back to the faculty members here, if they can both just quickly share, just to remind the group, and especially as students have so many great options to consider across, Ontario as well as across the country in terms of, programs that might be similar. So Sarah, over to you first. Why, in a nutshell, why chemical engineering specifically at Waterloo, maybe in comparison, not to talk about other schools, but comparing other programs that exist?
Okay, so I guess starting with why chemical engineering. Chemical engineering is everywhere. It's in every industry. We like to solve problems. We like to look at processes, improve them, make them safer, make them more energy efficient. We can look at little pieces of processes or big pieces, the process as a whole. So we're super, super versatile in what we can do, and you really do find us absolutely everywhere. In terms of Waterloo, things I love about Waterloo, of course, is the co-op program. So many great different experiences, so many opportunities to apply what you've learned or learn something in industry and bring it back to the classroom. Lots of different opportunities for that, to find out the things that you like to do and the things maybe that you don't like to do so much, which is also a valuable experience. I also love our capstone project because students really get to do something that makes a big impact, which not everywhere gets to do something like that. A lot of times it's littler projects, but we have a capstone project that students really get started thinking about in third year. So there's a lot of time to work on this and really produce something that you're proud of, and maybe take as you leave our program and do something with later.
Wonderful. Thank you so much, Sarah. That summed it up beautifully. And over to you, Ting, to highlight one more time a little bit about nanotechnology.
Okay, so as I mentioned before, if you have a COVID vaccine, you already experienced nanotechnologies. So this is to tell you how important, how much impact that is. And it's just the beginning, and it's just a small niche of what you're going to experience. And also the electronics area, that's all the chips is made of nanotechnology, especially the high performance. So everything, it control your electric car, it control your computer, it control your cell phones. So between those two alone, we are all affected by nanotechnologies significantly in the futures. So it's quite important. So why Waterloo? It's a great place. People are friendly, great professor. Everybody is great to work with. We have a new building, not quite new, but newer building, newer facilities. And as I mentioned before, we have a dedicated clean room. Not many university in the world can claim that. So you will be heads up in terms of your career wise. And we have a lot of labs that allow you to prototype your ideas, and many of the students alumni actually have startup companies based on that. So idea is one thing, but bring it to fruition is another story. And we are going to be helping you out along the way.
Awesome, awesome, awesome. I'm convinced. I'm convinced to apply. If I can, I'll apply to both chemical and nanotechnology. So fantastic. Thank you, Ting. For our last question, this will go to our students and alumni as we wrap up today's webinar, exploring both chemical and nanotechnology engineering. So just any final words from the student perspective, any advice, any words of wisdom that you want to pass along to students who are tuning in today that or on various scales, various ranges in terms of either knowing that this is the field for them or maybe, hearing about it for the first time today. So why don't we start with Annika for her final words.
Yeah, I guess maybe I'm a bit biased, but I think the University of Waterloo is a really great school for engineering. The professors are amazing. Like Ting said, they help you along the way, and they're always there to help you when you need it, as long as you just go and ask for help. So I guess if you're kind of unsure about what kind of engineering to do, I think nanotechnology is a great place to start, because you learn a little bit of everything at the beginning and then can branch out later on. So
wonderful, perfect advice. We can take biased advice. That's okay. We'll take it. Awesome. Kaylee, yourself for your final words.
Yeah, I would agree that Waterloo is a great spot. I think the co-op program really it's something that you probably are not going to be able to experience anywhere else. The thing I loved about chemical was that it was so versatile. All my friends are now in completely different industries doing all different things that you would not expect when you might start to think about chemical engineering. But really, as you're applying, I would say a big thing as well is just go towards what you're interested in. And even if you don't know exactly what it is, lots of people switch. You're not ever stuck. So don't freak out too much applying to one thing. Just go towards where you're really interested in.
Wonderful. Amazing advice. We're going to have to create a guidebook here with all these words of inspiration that is being left with the audience. Annette, over to you for your final words of wisdom to the crowd.
Yeah, so I guess in general, I'd say keep your mind open. So if you don't know what your calling in life is, that's okay. Especially if you come to Waterloo, you can do the co-op program and you can try so many different things. Don't limit yourself. This is kind of a general piece of advice. Just, be willing to try new things. And even if it doesn't sound like it's suited for you initially, you might be surprised. You don't know. So that's my advice.
I love that. I love that. Keeping an open mind. I think that's really important. So fabulous words, Annette. And Nuseba, you get the last words of the evening. Any final words of advice to our future students?
Yeah, basically just echoing what everyone else has said. I think Waterloo's a really great place, especially for engineering. There's just so much innovation going on. We have so many activities, student design teams to really help you learn new skills and exercise your thinking muscles and everything. So I just feel like when you're on campus, you really feel like you're there to learn and there's so much opportunity around you. So kind of like Annette was saying, don't be afraid to take on those opportunities and you might even make mistakes, who knows, but that's all part of the learning opportunity. So just be open-minded, be excited. A lot of your school experience is going to be determined by how much you participate and what you put into it. It'll be that much more fun if you go into it with an open mind and try to have fun and make the most of your time here.
Wonderful. On that note, we officially are concluding our webinar tonight. Hopefully you're all interested in learning more about chemical engineering and nanotechnology engineering at the University of Waterloo. There'll be many ways for you to connect with us in the coming weeks, so keep an eye out for emails coming your way. But just to give everybody an official close, a virtual round of applause to our experts, our panelists, our students, our alumni, our faculty. You all did an incredible job showcasing your experiences and some strengths of the programs. To our guests, thank you for joining us, no matter where you are located in the world today. Just please note that this recording will be sent to you within the next couple of days as well. So thanks so much again for joining us. We will awkwardly wave in the meantime, and we hope to see some of you in September on our incredible campus located in Waterloo. So thanks so much, everybody, and we'll give our farewell goodbyes. Thank you.